Think, Learn, Innovate.
Hi everyone. Today our topic is to find out the values of unknown capacitance and resistance using an AC bridge. Okay, it's a very simple topic, and I will take a numerical problem and I will solve the numerical problem. From there you can able to understand how to find out the unknown resistance or unknown capacitance for any AC bridge. So first of all, this is my AC bridge which is given in your problem, and the arms are given as A, B, C, D. All the values are provided to you guys: R2, R3, R4, C2, and R2. Now the unknown capacitance and unknown resistance is connected between the point A and B, and the current flowing to this point is I1. The current flowing to the arm B to C is R3. Current flowing to A to D is I2, and the current flowing from D to C is I4. At balance condition, always remember, at balance condition, no current flows through this detector, and so at balance condition, at balance condition, what we can write down is I1 is equal to I3 and I2 is equal to I4. Also remember that at balance condition, V1 will be equal to V2 and V3 will be equal to V4. So from the impedance point of view, that balance condition, always remember that Z1, Z4 is equal to Z3, Z2. Okay, this is your Z2, this is your Z1, this is your Z3, and this is your Z4. So I will write down the balance condition for the impedance. The impedance balance condition is Z1, Z4 will be equal to Z2 and Z3. So first of all, I will write down all the impedances here. What is my Z1? If I come here, Z1 is my R1 plus 1 by j omega C1, which will give me 1 plus j omega C1 R1 divided by R1. That's my first impedance. What is my Z2? If I come here and this side, my Z2 is R2, capital R2 plus 1 by j omega C2. That I can write down in this format: R2 plus R2 bracket j omega C2 plus 1 divided by j omega C2, and I have impedance Z3. What is my Z3? Z3 is only, we have a resistance R3 there, and similarly my Z4, I only have a resistance R4 there. So what I have done, similarly I have found out all my impedances. Now I will plug in these impedances in my equation. So I will go to the next page, and I will start by saying that Z1 Z4 equal to Z2 and Z3. Good. What is my Z1? So previously I have written down my Z1, 1 plus j omega R1 C1 divided by j omega C1, that my Z1, and what was my Z4 is R4. Similarly, my Z2 I will write down here as R2 plus this R2, and I have here j omega C2 plus 1 divided by j omega c2 and whole bracket. What is my z3? Is my earth. So this j omega and j omega will go away and I will cross multiply, and so I will get r4 c2 bracket 1 plus j omega c1 r1 equal to 1 plus r2 capital R2 bracket close j omega c2 in bracket, and I will get here is r3 and c1. Now I multiply both of them so that I can write down the real part and imaginary part separately. So first of all I will multiply this one. I get r4 c1 plus j omega c1 r1 r4 c2, and here I will get r3 c1 plus r2 plus capital R2 divided into j omega c2 r3 and c1. So first of all I will take the real part of it, and the real part is this one and this one. So I will equate the real part. The real part becomes, so I will say r4 c1 is equal to r3 c1. Now remember r4 this is c2, this is c2, r4 c2, I'm very sorry, this was c2. See r4 c2, the r4 c2 and r4 c2. Now what happened here is that I know r4 is given in my parameter, r3 is given, c2 is known, c1 is not known. So I will write down c1 is equal to r4 c2 divided by r3, and that gives me, what is my r1? So slowly now I will plug in the values of all of them. So first of all I will plug the values of r4, which is 2850 given, divided by my r3, and my value of r3 is 2000, it's given in the parameter, into my values of c is 0.5 into is microfarad, so minus 6 farad. And if I do the calculation, I get, what is my c1? After doing this I get c1 0.712 microfarad. So that's the value of my c1. So I have already got out my c1. Now I will find out the value of my r1. So after that I will take the imaginary part. See, this part is imaginary and this part is imaginary. Now considering imaginary part, if I consider imaginary part, I get what? C1 R1 R4 C2, which is equal to R2 plus capital R2. I got this, and I got C2 R3 C1. So after I got this equation, from here, see, I can take C2 off, C1 and C1 off, and directly I can find out the values of R1. So I will go to the next page, and my value of R1 is equal to R3 by R4 multiplied with this R2 plus capital R. So what was my R1? Then R1 is my, R3 is your value is 2000, and that value is 2850. Your one value is 0.6 given and another one is 5. So approximately, if I do with your calculator, you will get approximately 3.9. So I got the values of R1, I got the values of C1, and lastly they told us to find out the dissipating factor, and the dissipating factor D equal to tan delta 1, that's your formula, and that is given by omega C1 R1. So what is my tan delta then? 1 omega is 2 pi f C1 R1, 2 into 3.14, and your frequency is given as 450 hertz in your problem. I got my C1 few minutes back is 0.712 into 10 to the power minus 6, and what I have got my resistance R2 is 3. R1 is 3.9. So from this I can find out the value of tan del 1, and that tan del 1 is nothing as 0.00784. It's your answer. Hope this video is very important for you. It is very clear for you guys. If you have any question, please feel free to write down in the comment section box. I will try to bring more video of this kind of topic in near future. Thank you.